Yeah. Um, we talk about two important concepts in C++. One is called multiple inheritance. One is called virtual inheritance. I like to use this diagram to illustrate the difference between these two. One is the one on the right is multiple inheritance. That means you're not going to share the object area of your base class. So in this case, if you're doing multiple inheritance, then employee, student will have their own copy of their base class. So which means that you're going to have a two account object when you do multiple inheritance. Okay, this is one way to do it. And the example I used last week was you might need to have two different financial account. One related to your employee status. The other one is related to your student status. So that's multiple inheritance. For example, Java doesn't have this kind of multiple inheritance. Java only have virtual inheritance, but in Java, virtual inheritance is called multiple inheritance. So this is kind of confusing. If you're a Java programmer, your multiple inheritance is really virtual inheritance. And there is no such thing directly as multiple inheritance in Java. By the way, Java is a better design language. They use something called view to fulfill the purpose of the multiple inheritance. Thank you. Oh, wow. Well, I don't want to scare anybody. Okay, virtual inheritance, on the other hand, the example I use is that a work-study student, he's both an employee and also a student, and they share one account. And this account could be an email account. So you have the same email ID between employee status and student status. This is called virtual inheritance. I will explain to you why they call it virtual inheritance a little bit later. It's not to do with inheritance, it's more to do with how they implement. Okay, so this is the first concept we conveyed last week, the difference between multiple inheritance and virtual inheritance. To illustrate the difference, as a C++ programmer, last time I talked about memory layout. So what is a memory layout? Memory layout is exactly how the runtime system is placing your information regarding the data, regarding the object in the memory. How does that, I mean, this for most of the programmer, you probably don't need to worry about memory layout. The only thing you need to worry about is your program doesn't have a bug. If you have a bug, you might overwritten some of your pointer in some of the memory layout, which then this is more useful from the debugging perspective. So for example, I had this kind of bug before, is that because I have a bug and my program kind of overrides certain area such that when I call a function, it's not calling exactly the function I like to call. It's actually calling something else. So that's from the debugging perspective that it's good for you to understand the memory layout. But if you're doing system programmer, especially you want your program to be high performance and very efficient in terms of memory usage, then it's good for you to know the memory layout. So in the memory layout, you kind of, it's like you know something very low level. so you can play certain tricks to do some of the advanced programming concept, either for performance optimization or for the purpose of cybersecurity, or for the purpose of you just want to develop a program which is let other people don't really understand what you're doing. And you can actually directly play tricks at the lower level. And usually the vtable pointer becomes something very useful. So before today, I'm going to spend a lot of time talk about what is a vtable pointer, which we actually start to see that. But I want to also tell you what I did the last part of the course is that, okay, I want to know exactly what's the memory layout in the system or in the compiler I'm using for construct my for compile or a runtime for my C++ program. So what I did last time, I show you there are in fact two options. I told you the better option, but I'm going to tell you the other option as well. Actually get this out of this. And I was using a compiler option. Let me see, where's my code? Where's my window? It's probably this one. Yeah, this one is fine. So this is a line I use to generate. By the way, I should tell you that this part I highlight is the command line that I want to invoke the compiler to generate the output. And then this one, just to let you know, this is a very commonly used. This is called I/O redirection. This basically say I want to redirect my standard output to a file. So that means if you see this, that means whatever generate as std out, which is device number one, from the command line is going to be redirected to the file. Okay, this is just I/O redirection. Just show you if I don't do this I/O redirection, let me get rid of this. And it basically just generate in front of my terminal about all the layout. So each section represent a layout for a particular class. Okay, that's the idea. So I use I/O redirection is easier, so I can put this in a file so I can easily do something. Okay, this is called I/O redirection. You can I/O redirect a lot of things because the file descriptor 0 is input, file descriptor 1 is standard output, file description 2 is standard error. So depending on what kind of session, sometimes you use any Unix program, it generates tons of message, especially compiler. And you want to use I/O redirection to cap it somewhere so you can actually slowly process the information. But the point I will try to make here is you can see that this is a special feature that's designed in the G++ compiler for the compiler not try to compile your program, but try to tell you what is the memory layout looks like. Okay, I mean, just an example, this part is the compiler generate the output for the class work study. And we kind of trace, I mentioned that the first column is called the offset. So what do I mean by the offset? Offset means that from the first byte in the memory of this particular object, and then from there, how many bytes I need to skip to store a particular variable. I mean, for example, A1. A1 is a variable that's actually in the account, which means the account object. And that's from the first byte and skip 32 bytes. So the offset is 32. So you will see the offset concept a lot. You use this for memory layout when you access a file. You want to see what's the offset of this particular position of a file that represent from the first byte get to this moment. For example, you want to watch a YouTube video, you want to see what is the offset of a particular moment you want to enjoy. Okay, so you can see that there is an offset, some of the variable. And the other thing you want to see is that every single class except the account, the first 8 byte from that particular object portion, it must be a vtable pointer. We call virtual table pointer. Okay, for example, the object work study is starting with offset 0. And offset 0 is always a work study vtable pointer. Okay, and then you have for class account, as I mentioned, it doesn't have one. But in class employee, you have another one, employee vtable pointer. And then class student has a student vtable pointer starting at offset 40. So almost every single object, their first 8 byte of this particular object. In fact, in this particular layout, I have 4 objects. We have 4 objects. The first object is work study. The second object is account. The third object is employee. The fourth object is student. We have a 4 object, except account. Every single one, the first element is always a vtable pointer. By the way, I can easily make the account also have a vtable pointer if I actually create a virtual function. Let me try to do that, see how that works. Okay, I never done this, so it's always interesting. I hope I'm right. This is always the spirit of programming. We have to try it. Okay, you can see that I add a function here, which is called foo, is a virtual function, and this function does nothing. But I add a virtual function in the account. Let's see what's the difference. Okay, you see, now the account has also a vtable pointer. This one, the difference between the previous one and this one is I add a virtual function to the account. And therefore, each of them, work study has a vtable pointer, account has a vtable pointer, employee has a vtable pointer, now student has a vtable pointer. So somehow you got the idea that the vtable pointer has a relationship with a virtual function. In fact, it also has a relationship with a virtual inheritance. Okay, let me go back to explain why I easily pick up. I said, well, why account doesn't have a vtable pointer? I said, oh, of course, it doesn't have any keyword virtual. So let me go back to the code. So see that if you look at this portion of the code, if you look at this portion of the code, talk about the specification of account. And before I don't have this virtual void foo. That means the whole block of code, I don't have anywhere which I have the keyword virtual. That's why it doesn't have a vtable pointer. But if you look at the employee, even though it doesn't have the virtual function, but it has a virtual inheritance. It has a virtual keyword here. So it will need to have a virtual pointer. And the same thing for student, it has this part, and the same thing for work study, and it also have a virtual. In fact, if you remove the virtual, you will see the memory layout is going to change. Okay, and that's kind of so you kind of get the idea. Whenever you add a virtual, we're having a virtual table pointer, which is essentially that's number one. We have a virtual table pointer, but the other thing is important. I want to tell you, if you look at the virtual table pointer in the memory layout, it not only say is a virtual pointer, but it's a virtual pointer for a particular class. You see that? Before this two keyword virtual pointer is always the class name. Class work study, class account, class employee, and class student. That means it's not only virtual pointer, virtual table is related to the virtual keyword, but also it's related to each of the class. So which means that, for example, class work study, you have a one, class account, you have a one, you have a separate table. It seems to me, it seems to us, is being bound to a particular class. So you can start to imagine for each of the class you're going to use within C++, you're going to have a special area called virtual table that's specifically dedicated to that particular class. Okay, so that's one thing I want you to know that. But I want to show you another way that you can actually get it to work. Okay, another way. You don't have to use a memory layout. Okay, sometimes I have to tell you that some of the environment or some of the compiler, you might not have this memory layout option, or some of the compiler might have a different flag to do memory layout. Okay, but I want to tell you that even though you don't have memory layout, how do you actually figure out the memory layout? Okay, I'm going to use vi.cpp to do this. It's easier. Oh, by the way, before I do that, I want to tell you that this is the result from the memory layout, a graphical representation about what we did. Okay, this is a result. If you remember, we kind of track. Um, we have the first A byte is a vtable pointer, assuming 64-bit architecture. And the second A byte is the only variable W1 within the work study class. And then shift 16-bit, you're going to see vtable pointer for employee and the employee's data. And then add another 16-bit, which is 32. You're going to see the account. I mean, this one was drawn without the virtual function. So if the virtual function, I'm going to add another vtable pointer between the green box, which is employee, and the yellow box, which is account. Okay, this was showing before we add the virtual function. Okay, so you can see that the memory are compact together compared to multiple inheritance. You see that multiple inheritance, because I don't have any virtual keyword, everything is compact. I don't have, everything is about data, nothing about vtable pointer. But when you start to use either virtual function or virtual inheritance, you're going to see that pointer being inserted in certain way. Okay, I'm not going to tell you in detail why they arrange this way. There is a pattern that you can actually find out that why, for example, this is something you might notice that in the multiple inheritance, you see that it's always a count, means that if you're a base, you come first, and then you go to the derived. So base is account and derived is employee, and work study is the derived two, the second level derived. It's always follow that order. But the virtual inheritance is a bit random. It doesn't have a clear content, sorry, clear pattern, but always the how do I say that? The the class that was originally create the object is going to go first. So what was this one on the right? It was a work study object. That's why work study go first. And the second red arrow, that's actually when you're casting, that represent the employee object. So employee go first. So in that, they have this pattern. But the pattern between, say, whether the account is in between employee and student, that is depending on the situation. Okay, so that's the way. But I want to tell you that this particular graph was generated by the memory layout from the compiler, but we can do it the same way using pointer. So I'm going to show you how you can do that very quickly. Okay, over here I have this, assuming I don't have that virtual function. Maybe I just add a virtual function. That's fine. Okay, I'm going to create the work study WS. Let me get rid of this part. So let me do this. So I first print the work study object. And then I'm going to print, let me see, this one I want to print the address, so I'm going to do P. And work study is going to be NW Felix. Okay, this one I'm actually printing the memory address about the work study object. And then I'm going to print the work study, the address of the W1, which is the only variable. I call it attribute. I'm only printing the address so I can see the memory layout. Stop W1, and then I put N, put the address. Let's try to compile this program. Okay, if I run the a.out, you can see that it generates two addresses. One is the object, one is the attribute. You can see that the difference is 8. The difference is 8 because they skip 8 byte as the virtual table pointer. Okay, and the other thing which I want to tell you is that I want to print the virtual table pointer address, which we can see what it is. I want to print the value of the let me call it V table PTR pointer. So how do I print it? I have to treat this address as a pointer. So I have to call this as void star star. I want to cast this. I hope this works because casting is always tricky. Let me see. Address, I treat it as a address, and then I do a star. Okay, this is a bit complicated if you don't familiar with the syntax of pointer, but this is essentially saying that I'm treating the first byte as itself is a pointer, the content, then I take the value of that pointer, then it should give me the pointer value. So let's see if this will work. It might give me some warning. Okay, I'm missing one. Okay, I'm missing one. I'm missing one parenthesis, I assume. Okay. Okay, let's take a look. So you can see that I'm actually giving you that this is the address of the object, this is the address of object, but then this is the value that's the pointer itself, the vtable pointer for the work study. Okay, this actually give you idea. So you not only know the memory layout, but you actually know the vtable pointer pointing at the table. So now I can extend this to do pretty much everything else. So let me do just two. It's probably easier. Let me do employee. Let me do student. And you can do the same thing for the other two. Okay, over here I'm going to do casting. I'm going to cast this as a student. So that's why you see that casting sometimes is fairly important in C++, especially they are related to inheritance. Okay. And the same thing, I'm going to do casting here. Wow. See how many, I hope I'm have enough. Okay, good. And this part, I'm going to do the same thing. Okay, I think I'm going to do, and this one is going to be S1. That should be enough. Okay, just look at the S1. Okay, let's take a look at the result. Okay, first let's verify the work study and the student. The work study is FA, the first byte, and the first byte of the student is 428. Can someone calculate what's the difference between these two? What's the difference between hexadecimal 3F8 and 428? So 28, 2 is 32, right? 2 has that 20 has decimal is 32. So 32 plus 8 is 40. And then 40 plus you have a more here because FA and 00 is 8. So you have 48. So between work study and the student is actually the distance is going to be 40. So let's actually check on the offset based on memory layout. Take a look at here. This one is the beginning is a 0 and the class student is 48. That's exactly what we expect, right? So you can actually use printing the address from the memory hierarchy, from the inheritance hierarchy, and then realize that the information you're getting in terms of offset is consistent with the memory offset that provided by the compiler. Okay, so that's just want to tell you what it is. But the other thing which I want to tell you is equal. If you check the rest of the attribute and things are different. But the other thing I want to tell you is that have you noticed that the work study vtable pointer value, this one 4030, is different from the vtable pointer for the student. They're close, but they are not the same. They're about distance by 50 hexadecimal. So which means that they're being placed in an area which is a far away, pretty far away from the object, the real object, but they have a pointer somewhere else. Okay, so that's interesting. And I want to tell you that just simplify. So every single class, you're going to have a what I call virtual table. Every single class, you need to have a virtual table if you're going to use virtual function or virtual inheritance. Okay, so now I'm going to talk about why virtual table. Okay, by the way, any question at this moment? Okay, memory layout is important, okay, especially for us to try to do some kind of memory optimization, try to have a high performance program. You should know your program how, I mean, for example, if you decide to use virtual function, there's a cost you're going to pay because you're going to use more memory. You're going to use some kind of indirection, which I'm going to show you next. Okay, so I'm going to recap. Go back to, hey, wait a minute, why I'm here? No, I'm not here. I want to go this one. I want to use this one. Okay, I'm going to recap what we did with the virtual function. So we talk about virtual function. We say, well, what's the difference between a virtual member function versus a regular member function? So we say that a regular function, which function to call, it depending on at the time when you call them, what's the type. Okay, whatever type it is the function you're going to call. But virtual function is somewhat different. Virtual function is essentially saying that it really depends on what was the class when you originally create the object. Let me actually pull out the virtual function slide. I think that will help you to remember what we did back then. Oh, wow, my goodness. No, I don't want to go that way. Let me use, where's my virtual function slide? Oh, okay, I'll use this one. That's pretty good. Okay. No, this one is good. This is the slide I used to explain virtual function a while back, or something similar to that. Okay, so if this is the regular member function, remember I have a single inheritance, my base and my derive. So which function to call, it depending on how you casting it. So for example, the object 2, if I cast as my base, then essentially it will be the object 2 will be treated as my base instead of my derive. Therefore, it will call the function foo in my base. So essentially in the regular member function, depending on what's the type, after you do the casting, and then it will determine what's the data type. By the way, I should say, what's the data type at the time you make the call? Then it will determine which version of the member function you're going to run. Well, however, if I do a virtual function, you can see that it's the same piece of code. By the way, these two, they're exactly the same piece of code, except when you declare the member function foo, you declare either as a virtual or as a non-virtual. So regardless, so essentially, regardless what's the type of object 2 at the time when you make the call, it doesn't matter. It will always call the my derive. Why is that? Because my derive, the object 2 was created as a my derive. You see that? The object 2 was created at the time it was created, it belonged to the type my derive. Therefore, regardless you cast, you move the pointer here and there, it will always call my derived version of virtual function. That this happen when we do dump to JSON or JSON to object. It's always say, well, which one you created, which type you created to determine which version of the function you're going to use. Okay, this is a concept as a user to use virtual function. I hope you remember this is one of the critical, unique perspective from C++. I mean, in Python or Java, you never need to worry about this kind of stuff. But in C++, you have to worry about this is called polymorphism, meaning that regardless how you change the look about an object. So what do I mean by casting? Casting is essentially change the look, the outlook of a particular object. No matter how you change the outlook of an object, it will always call the version of a function at the time it was created. Okay, so that's called virtual function. Okay, now I have to go back to my critical question I want to ask you. So the question is that I said, well, virtual function, the object was determined by the object created, and then it doesn't matter how you cast differently. I will always call whatever function at the time it was created. But the real question I want to ask you is this question. But how does a compiler figure out which function to call? Let me actually highlight this question because this question is so critical. So let me repeat this question. This is the question, by the way. We don't have an exam this quarter or this semester. Sorry, I'm still believe I'm in a quarter system. So this is my final exam question. Always have this question. For virtual function, how does the compiler figure out which version of the function to call? How does compiler know? What is compiler? Compiler is doing code generation. It's going to generate code to support every single function call. But on the other hand, the virtual function is determine which version to call depending on at the time the object was created. But now after it was created, after a while, you suddenly have a call to call that particular virtual member function. But then how does a compiler figure out which version of the function to call? Anybody want to provide a guess? How does a compiler figure out? If you can answer this question, I will let you pass. No, I'm just kidding, okay?
它把函数的存在那个 object 上面。
Okay, but okay, that's good. You said you want to store something in the object, right? But the object won't be created until runtime, right? The object, see, compiler time is translate your code into an executable, but the object won't be created until the object was created at runtime. So any of the object-oriented program, the object won't be created until you start running it. So the correct answer to this is compiler, they don't. Compiler cannot figure out. So this is important. I mean, for all the programming language, you realize the role of compiler. By the way, for electrical engineering, compiler is a very important technology. You're going to do IC design. IC design is all about compiler, compiling a design into. So this is a compiler. You have to know the role of a compiler. For virtual function, the compiler simply doesn't have the knowledge because the compiler doesn't know when it was created. By the way, it could be possible that this line, when you call, it was introduced by different objects. They all belong to different type. Okay, if you think about that, this is one of the hardest concepts. It's not so hard as a programmer, but it's very hard as a programming language designer. When you actually develop the compiler, you always have to figure out, well, how do I write the compiler in order to translate this concept into machine code to execute? And the correct answer and the short answer is no, the compiler cannot figure out. If you think about that, the compiler cannot figure out. So I will let you think about for the rest of your semester to say, well, why compiler cannot figure out? If you want to discuss, I can provide you a one-on-one session to talk about that. But I'm actually going to tell you that how I can determine this at runtime. Okay, the compiler, I don't know, but how about runtime? So let me make a quick high-level summary about how high-level this can be done at runtime, and then we will see some example. Okay, so here's the story. Okay, I don't know I don't know which function to call at runtime because what? Because I don't know whether this object, which class the object was created. By the way, what's your name? What? Yuxuan. Okay, I know you're a great student. You know a lot. You actually already point out some possibility about the object. So the thing is, what I did is that if which function to call should depend on which class this object was created, then I can actually have a table that's associated with a class. And, and this class will contain a bunch of what we call function pointer. By the way, I should ask you, have you heard about the concept called function pointer? So pointer is pointing to an object, but a pointer to a function, that means the function. By the way, what is a pointer? Pointer is always pointing to some address. So a function, the function code is also an address. So pointer to function means that I actually has a record about where that function is. Okay, I will talk about function pointer. If you're not familiar with this, this is so critical. In C++ programmer, you have to know what is a function pointer, how to call a function pointer. Okay, so I will store a table of function pointer, and this table is called V table. And each class has a V table for this particular class, which has all the member function for all the object that was created has to call. Okay, so the compiler can actually generate the V table pointer, decide where it is. So whenever you create an object at the time, remember it's determined at the time the object was created, then at the time the object is created, the runtime is going to put the value of the vtable pointer into the object instance. Does that make sense? Let's actually take a look at this following example. So for example, this one is called a class base. Okay, it's a class base. Remember, you see that I'm kind of have a hiding somewhere here. It's called v pointer, vtable pointer. That vtable pointer is the first 8 byte of a class, sorry, an object created from this class. The first 8 byte is always a vtable. And then for each of the class, I'm going to have a vtable. I'm going to have a vtable. And this vtable, okay, this is not a complete layout of a vtable. Vtable not only deal with virtual function, but also deal with virtual inheritance. Okay, so I'm not going to virtual inheritance part, but just look at the virtual function. So, okay, so this is the vtable pointer for class. So you can see that I have a 3 pointer to a function. And it's point to member function 1, member function 2, and member function 3. So whenever I want to make a function call on a object related to the base, if this object was created as a class base, then the vtable pointer is pointing to this particular table. And then from this table, I can actually retrieve the function you're going to call. Are you going to call function number 2? Then from here, I find the function pointer for the base class version of function point 2, and then I'm going to really call this function. Okay, so the compiler doesn't know exactly, but compiler provide enough information such that at runtime, you can find the vtable, and then from the vtable found the corresponding function pointer, and then really call that function. So, okay, number one, so virtual function is more expensive. Have you noticed that? Usually, if you want to call a function, you can do compiler optimization. It's direct. Compiler know precisely which one to call. But when you have a virtual function, you have to go to the vtable and found the one that's then called. I mean, you have a few indirection you need to make. Okay, so that's Number one. Okay, number two, let's go to the derived one, which is the first level base class. You can see that now I have a different V table. The V table is going to be derived one class, and I have for this one, I might have a one function. If you call derived one function one, is going to call derived one. But if you're calling base, and it's going to call the parents. Okay, this is a design because the derived one doesn't have a new function zero and function, doesn't have a new function two and function three. So that's why you use your parent. So number one, if you are created as a derived, at the time the object was created, your vtable already pointed out to the derived one's vtable pointer. So now you can go there to find the right function to call at the time you're going to really make the call. So you see that the time when the object was created until the time is really calling a particular function, such as function one, there was a time difference there. So at the time the object was created, all I'm doing is just set the vtable pointer value to be the table belong to that particular class. And then later when I call, I would just go to that table and found that out. So that's a vtable pointer. And more complicated, if I have a second level derived base, derived one, derived two, is the same thing. Now I have a derived two vtable. And such that when you want to make a call, if you want to call function two, it's going to call myself, but function one, I'm going to call from derived one, and function three, I'm going to call the base. So you can see that now I have a lot of, this is what we call polymorphism, that you can have multiple ways to determine which function to call depending on which class that you're going to, which class you use to create this object. And at the time, we actually set up the vtable pointer such that you will be able to access the vtable of that class that helped the creation. Okay, I'm going to stop here, and I hope you understand this. This is pretty challenge knowledge about C++, because it's not just about using the language, but you know a little bit about at runtime, the information was managed. Okay. All right. So I will see you on Thursday. So Thursday, we're going to start working on your final project.